All right, I wanted to take this opportunity to do a little bit of an introduction to Python. So, for a lot of you, this may be repeat or something that you already know, but I just wanted to cover it just to make sure that everybody's on the same page and understands the basics of Python. I know as we start to go through the more complicated things through the assignments, um, sometimes we miss the basics and just assume everybody knows. So I'm going to go through the basics. Please take the 10 minutes or 15 minutes or so this is going to take to walk through it. And then if you have any questions, again, please let me know. But in general, I just wanted to put this together for you. So I'm going to do an introduction to Python. And what we're going to do is we're going to base it on some baseball stuff. So hopefully you're a baseball fan, but some of the exercises and stuff will use baseball. Feel free to use your own variables, your own names, teams, whatever else, but just to give you an idea. Um, Python is a general purpose programming language. So why it's so important, especially for the field of computer science or the fields around computer science, is because it's this general purpose programming language and there's a big community of users around Python. So people are using it for web development, desktop applications, mobile app development, a lot of usage now in artificial intelligence, specifically in the area of machine learning, and then data science in general. So you're going to come across Python quite a bit in computer science. So it's definitely a good language to learn. It's a fairly easy language to start with. It's definitely a lot easier than Java or C++ or some of the other introduction to programming classes, but it gives you a lot of the same information and requires some of the same thinking. So Python's very popular that way. So what we're going to do today is we're basically going to talk about the basics. So it's not required that you install Python for this course. Everything's happening through Zybooks. I would recommend it only because it gives you the opportunity to really learn it outside of Zybooks and start playing with things a little bit more. But it's totally up to you. We're going to use Anaconda, which we'll talk about in a few minutes. It's a real easy installer. You don't have to worry about setting paths and all of that stuff. You can do everything within Anaconda, and then all the packages that you're going to need and stuff like that are usually going to be included. We're going to use Spider as our IDE. It's got our EPL, which is kind of that real-time interpreter, which is what we're going to spend most of the day today looking at, or most of this recording. And we're going to talk about the fundamentals, so variables, functions, conditional structures, loops, and classes. That's what we're going to talk about today, just to get everybody on the same page, making sure they kind of understand the basics. So again, for this series of tutorials, we're going to use Anaconda, individual edition. It's free. You can download it directly from the link here at anaconda.com. It includes right now, as of this recording, Python 3.8. And then it's Spider 5.0.3. Now I think it comes with 4.25. You're fine to use that, but you can also, it's going to give you instructions for how to upgrade to Spider 5.0.3. So if you want to use the same version that we're using here, I'd recommend upgrading it. So this is just a download. It's a fairly large one. It's like 440 megs. Shouldn't take very long, but it is cross-platform. So you can download it for Mac, you can download it for Windows. So I think it's a really good tool for learning Python. Once you download it, you're going to open up the Anaconda Navigator. And as you can see here within the Navigator, it's going to show applications that you have already installed. Some come with Anaconda, some you may have installed separately, but it's going to allow you, this is your launcher for all these different applications where, like I said, we're going to spend time in Spider. And so in Spider, if your version doesn't say 5.0.3, that's fine. You can just hit launch. It'll give you some instructions to upgrade, or you can use whatever version. We're just doing some basic Python to start, so it shouldn't be too much of an issue. This is just a screenshot of Spider. When you open it up, typically you're going to have two sides of it. One is your text editor. You're going to create .py files if you want to save them for later and run them later as applications. We're going to spend most of our time on the right-hand side. In fact, my screen's going to look a little bit different because I went console full screen, just so we can run things real time as we start to look at some different code. And so hopefully you're able to view it well and you're able to see exactly what we're doing. And I would definitely follow along. I don't have any files for you to download. I really want you to follow along on what we're doing here. I think that's the best way to learn. So when we talk about variables, there's a couple things, and here's an application that we're going to look at in a second. I shouldn't say application, just a script. But the first thing we want to do is declare a variable and initialize it. And we'll look at what that means. So declaring a variable just means that, we've got a variable here, P for player, for example. The initialize it is that equal sign. So we're assigning a value to it. Even if you assign blank string or 0 or none or whatever else, I would recommend you just initialize it. One thing is you can't combine different types. So this is something that becomes a stumbling block. So if we're doing a concatenation, for example, we want to do a string that says my batting average is, and then I do a plus sign and use the batting average variable, but that batting average variable is an integer, you'll get an error when you try to print that. You need to convert it, and we'll talk about that a little bit. And then you've got global versus local, which becomes a little bit confusing. So we'll talk about those as well. So let's look at variables to get started. So I'm going to go to Spider, and here's my console screen here. And what I want to do to get started is just do clear reset. Even though if you've never used it before or you're not sure the last time you used it, do a clear reset so we can clear out any variables. We're using letters for variable names, so there's obviously it makes something maybe memory, or we're creating functions and stuff like that that may be in memory. So we want to start from a clean slate. So this is Spider. So the first thing we're going to do is we're going to declare a variable. So we're going to use the letter P as in player, and we'll pick a player. So I'm going to use Bellinger, and it's lowercase, but that's fine for this exercise. And I'm going to hit enter. You don't see anything happening, but in the background, Spider, or the Python interpreter, is saving or assigning the value of Bellinger to P. So if I put P here, then it's going to tell me it's Bellinger. So I know that it's saved there. And I can overwrite it, and I could say P equals Kershaw, for example. So you could tell I'm a Dodger fan. And if I go to P here, I've got Kershaw. So in general, that's just kind of a global variable. So I've already set that as P. But what I may want to do is do what's called a local variable. So a local variable really lives within a function. And so we'll talk about functions in a little bit. But if we do a function, so let's say we want to do a function called myPlayer. And we'll learn this syntax a little bit more later, but we start a function with defining the name of it, and we put it in parens. Since there's nothing in the parens there, that means that there's no arguments that we're passing to it. It's just a function. And what I may want to say is P equals bets. So another player. And then in that function, I want to do a print statement. And I want to say, go ahead and print the player name. So I want to output it. And so that's just my basic function that I'm creating. So in order to call it, what I want to do is I want to say myPlayer. That's the name of the function. And it should go ahead and it should print the name of myPlayer, which is bets. But it's printing bets because bets is local into that function. If I hit P by itself right now, I'm still going to be in Kershaw. Kershaw is my what's called global variable. It has global scope. And within the function, I really shouldn't be using the same variable names as I do as global. It's not a best practice, but I am in this case. In that function, it's using the local variable of bets. So one way we can avoid it and make sure that we're keeping everything in sync is we can go back to our definition and we can enter and let them know that we're updating let the interpreter know that we're updating the global variable. So if I go ahead and I type this again, the global variable or the local variable is bets, and if I do the P, the global variable is bets. So again, that's it's called scope. And so I want to make sure that my variables are using the right scope. And so ultimately, if I have global variables that I'm going to use throughout my script, I want to put those outside of any functions or methods or anything like that. If there's specific variables that I'm going to use for calculation within a function, and we'll look at those, then we can just go ahead and define it in that function. So that's the basics of variables. There's different variable types. There's strings, there's integers, there's Boolean that we're going to deal with in this course. But again, overall, you just want to get used to the basics, which is we assign it, we declare a variable, and we initialize it. We don't combine different types. So it's strongly, Python's considered strongly typed. We want to make sure that we use the correct types and combine the right types, and we'll see some samples of that as we move forward. And then also that there's global and local variables. And so we want to make sure that when we're using variables, hopefully we're using them in the right scope, and we're not using the same names globally and locally, because that can get quite confusing. So again, just a real quick update on that. I'm going to do a clear reset so we can start from scratch, and we are going to look at functions. So functions are something you're going to be doing a ton with. And there's different types of functions. There's functions like we just created that don't take any arguments, that are just doing some sort of calculation or return. There are some functions where we're doing a calculation. So maybe we're taking in 2 arguments and we're using it like a calculator and saying 2 plus 2 equals 4, and we're doing that calculation and we're printing it. And then there are functions where we may just be concatenating strings or just talking about a list of strings or something like that. So there's a lot of different types of functions that we're going to get into, and we're going to look at some of the basics here. So let's do kind of a repeat of the one we had a little bit before, but we can do a function around teams. For example, to function team. And within that function, all I'm going to do is print the name of a baseball team. And you could put whatever you want there. It doesn't really matter. It's just a basic print statement. And so that's the function. That's all it does. So every time I call this function, it's just going to print Dodgers. It's not anything exciting. It's pretty basic. So if I were to type into my interpreter and say func team, it's just going to print Dodgers. So very basic stuff. But what I may want to do is create some sort of function where I'm actually allowing the user to give me some input. So you'll see within Zybooks, for example, it's going to ask, what's the input we're going to be taking in, and then it's going to take that input and run through a bunch of functions and test it. So if I look at, for example, a function that takes arguments, let's say, not an original name here, but function 2 players. I'm going to take in 2 players. I'm going to take in player 1, and I'm going to take in player 2. That's all I'm going to do within this. Make sure on your first line of a function you always end it with a colon, or else you're going to get a syntax error. And in this case, I'm going to print, but I'm going to print and concatenate player 1. I'm going to add like a space in there, so those quotes means it's a string, and I put a space in there, and player 2. So that's all my function does. But if I call the function without anything in it, so I just call it the same way that I called the previous one, it's going to give me an error. It requires 2 arguments, player 1 and player 2. And I know that it's a string, so I want to enter those as strings, so I'm going to use quotes to enter it. So if I go back to my function 2 players, let's enter 2 players. So we'll do the catchers, Barnes and Smith. And if I hit enter, then it's just going to print Barnes space Smith as a concatenated string. So you can see I'm taking arguments in, and if I'm asking for arguments, unless it's default or optional, I'm going to get an error. So we'll learn later around error handling and how to do some try catches and stuff like that. So we're not giving our users this type of error, but that's what's going to happen if we don't put in our arguments. The last thing I'm going to do is a calculation. So let's do batting average. Say function batting average, and the 2 things we need for batting average are at bats and hits. So those are the things that we're going to use. We're going to put a colon at the end, and you'll notice in the interpreters it's automatically doing the indentation for me. Python gets very picky about indentation, so you want to keep an eye on it and get used to it. And as you're learning, I would just use the interpreter to start typing in, and that way you can practice indentation and see where it all belongs. So in this particular case, we're going to return a value, and that return value is going to be hits divided by at bats. That's going to give us our batting average. So we're just doing a calculation, so we say function batting average, and in there, let's say the person has 300 at bats and has gotten 30 hits. Probably not a great batting average, but we'll see. So we put that in, and then it's, you know, a .1 batting average, batting 100. Not going to stay in the major leagues with that. So overall, that's what functions look like. Different types of functions. They're all basically doing the same thing. They all have basically the same format, and you're going to get used to these as you look at them more and more. So I would practice doing different functions, different types, pulling arguments in. You're going to get into defaults and stuff like that, which we'll get into in future sessions. Again, this is just meant to be a real quick catch up. And actually, we're spending a lot more time than I thought we would, so I lied. It's going to be more like 30 minutes than 15. But the other thing we're going to look at is conditional structures. So every language has a conditional structure, and I'm doing a clear reset. Every programming language is going to have some sort of condition. So we want to be able to say, if something is true, do this. If it's not true or else, then do that. So that's what an if statement is about, and that's a conditional structure. We use this a lot because what we may say is, if somebody has a batting average over 300, then say they should be MVP, and if somebody has a batting average less than 100, they should be in the minor leagues, or something like that. So we want to be able to use this to do some calculations and to tell us some information. So let's say I'll do something really basic like a home run leader, or who's going to be the home run leader for a season, and it's probably pretty obvious when we look at the numbers. But so I'm going to do a function of home run leader, and in this case I'm not going to use arguments, but I'm going to define some variables. So I'm going to hard code is what it's called, two variables, and I can do two variables on the same line. I don't have to do separate lines for variables. So I'm going to say home runs 1 and home runs 2 are going to be my two variables, and home runs 1 is going to be 75 and home runs 2 is going to be 70. Okay, so I'm saving those two variables. Those are local variables. They're defined within this particular function. And so now I'm going to do my conditional, and I'm going to say if home run 1 is greater than home run 2, which looking at it we could probably tell, but this is just an example. It's going to do my indentation for me, which is great. I do want to put a colon after my condition as well, so you do want to get used to that. I'm going to create a new variable called the HR king, and it's going to say the first player, so HR1, is the home run king. So if home run 1 is greater than home run 2, so in this case if 75 is greater than 70, it should go ahead and say that HR king is, we're going to write to that variable and say the first player is the home run king. So we're not writing to that variable yet, we're not declaring it, or excuse me, we're not initializing it yet. What we're saying is if that happens, initialize the HR king variable with this particular string. Then what I want to say is, because there's cases where maybe they're tied, maybe they both did 75, so I do what's called an elif. And I could say elif HR1, now we use two equal sign to do comparison. One equal sign is for initializing or assigning a value. Two equal sign is for an equal sign, or is for comparing two numbers for equality. If HR1 is equal to HR2, again, don't forget your colon, then we're going to say HR king is equal to, there is no king. They're the same. And then finally, the one thing missing is, well, what if HR1 is less than HR2? Now, we don't have to explicitly say that, because that's really the only condition that's left. We've already defined if it's greater than, the first player is the HR king. If it's equal to, there is no king. So really all that's left is it's less than. So I'm going to say else, and I put a colon after it. I don't have to put the condition in anymore. HR king is equal to the second player is the home run king. And so I'm going to hit enter. And at the end, I'm just going to print whatever value assigned to HR king. So that's my function. So in this case, because I've already defined the values in it, I'm not going to pass any new values to it. I'm just going to say function HR leader call it. And as you can see, because 75 is greater than 70, it assigned the value of the first player is the HR king to HR king as a variable, so the print statement pulled that. I can look at it again and we can test it if they're equal. And I just use the up arrow to go back to this function that we already defined. And now I can say function HR leader just to make sure this is working. There is no king. So that's how conditional structures work within Python. The last thing I want to introduce you to, excuse me, not the last thing, the second to last thing I'm going to introduce you to loops. There are two loop statements, and you're going to use loops a lot. There are two types of loop statements within Python that we're going to be discussing. The first is a while loop, the second is a for loop, and we'll see what the difference is. A while loop basically says while, and we'll use our home runs again, home runs are less than, I don't know, let's say 10, using a colon. So while home runs are less than 10, we're going to print the home runs, we're going to do a home run count, and then we're going to increment the value of home runs because we're using a counter. So it's going to go through and it's going to start with 1, and then it's going to add 1 to it, and then it's going to go to 2, to 3, to the 4, all the way up until it no longer meets the condition of being less than 10. So let's look at what that looks like. Sorry, I need to define a value for HR. So 1, 2, 3, 4, 5. So I'm saying HR starts with 1, and then while HR is less than 10, we're going to go ahead and print it. And sorry, I forgot to put that. I forgot to assign a value to HR first to get started. So the next thing we want to do is we want to do a for statement. So for statement is a counter. So we'll use the same, we'll use a different variable. Let's do for at bats. All right, in the range. So we're going to use a counter of 5 to, I don't know, let's say 15. So we're going to use a counter. And so it's going to pull a number from 5 to 15, and it's going to keep going. 15 is non-inclusive, just like we did less than 10. This is going to look like less than 15. So I should see a list of numbers that go 5, 6, 7, 8, 9, 10, all the way to 14. So I do my colon at the end. I'm going to say print my at-bats. And I double click it, and that's going to do 5 all the way to 14. So it's a for loop. Where for loops become important, and these are the ones you're probably going to use the most of, is that you may want to look through a list or a dictionary or an array or whatever else and print everything out. So let's look at what that looks like. We're going to create a list here called NL West. And in the NL West, we have 5 teams. So we're going to say there's the Diamondbacks, there's the Dodgers, there's the Giants, try and do this in alphabetical order, Padres, and the Rockies. So we've created this array of 5, or list of 5 different teams in the NL West. And so what we want to do is just go through the list and see and print them out evenly. So I can say for T, for teams, in the NL West, which is already just defined, I want to print the list of teams. And so it's going to go through that list. So we're going to see this a lot, where we've got this list and data and text, etc., that's coming in, and we want to just pull out certain values, or we want to look for certain things, and we want to iterate through a particular list. So that's what a for loop is for, and while as well, but those are for iterations, to iterate through a list or iterate through numbers or whatever else. So we're going to do a clear reset, and I want to talk about one more thing. You're going to get into classes a lot this week. And so let's talk about classes here. The idea of a class in object-oriented program is I can define attributes around a class, so common attributes around things. So maybe I have a class of furniture, and all furniture has a material, and all furniture has a function. But then a chair is a type of furniture, so it's going to subclass out, and all chairs have legs. So it has a material, it has a function from the original class furniture, but then it's going to add additional values like legs. All chairs have some sort of legs, for example. So that's what classes do, is it allows us to put some information together. It allows us to share information between classes, and that's what we're going to look at a high level right now. We'll go into this more detail next time. So let's say we have a class, and this is how we define a class. And let's say we have a class that's a favorite player. So again, you probably guessed it, just like we define functions and conditions and loops, we're going to put a colon at the end of our class. And what we're saying here is we've got a class named favorite player, or fav player. And all favorite players have two things. They have a name, and this self keyword is kind of like this, but it basically says I'm really I'm really initializing name as just being itself. And we'll talk about self in a second, or a little bit more, but name is just kind of a constructor here. The self is kind of a constructor here. So we're going to say define name, and then underneath the name we're going to print my fav player is Kershaw. Okay. Whoops. My fav player is Kershaw. I forgot the parens. Okay. And then the next thing we're going to do is we're going to say all players have a position. And in this case, I'm going to say self, but I'm also going to ask for some input for an argument, which is a position string. So what I want here is that when somebody calls the class, that they need to tell me what position that the person is playing. And we'll see what that looks like. But I'm doing define position, and I'm saying self and position string. So even though there's not an argument in the class function, there's an argument to this particular method within the class. As usual, I forgot my colon. And I'm going to say print Kershaw's position is, and I'm concatenating here, so I want to make sure that the person enters in a string, position string. Okay, and that's it for my class. So I've got two things here. I've got a name, I've got a position. For each one, I'm going to print some sort of string, and I'm asking for an argument on my position. Now what happens with classes is, now if I call it, just like we were calling them before, like functions before, I'm going to say fav player, and then I'm going to put in a position, pitcher, and enter. Oh, whoops, I'm sorry. I need to do, this isn't a function. I need to do a main function in here to run this. So I'm going to define main, and I'm going to say this isn't calling like a function. I need to create a function that's going to call this class. I'm going to say defunction main, or defining main, and I'm going to say f equals, so the f variable is going to be the instantiation of the class. Excuse me, I apologize. And then now I can call the methods. So f.name, there's no argument here that's going into name, so that's automatically going to print Kershaw. And if I say f.position, it's going to require a string. And that's where I put my pitcher. Now, when I call my main function, my favorite player is Kershaw, and Kershaw's position is a pitcher. So I've created a class. I can call that class with a function. That function instantiates the class, and then once that class is instantiated, I can now use the methods within that class, which in this case happens to be name and position. Now what I could do is I use the example with furniture. I could create a subclass. So I could say class, my second favorite player, but I want to pull the information from fav player. I don't want to introduce or reinvent the wheel. So I'm going to create that class, and it's also going to have a name. And let's say it's self. But in this particular case, I'm just going to pull the name from fave player. I don't want to create a new one. I already know that Kershaw is going to end up being my favorite player. So I'm going to go ahead and call that method immediately, and I'm just going to say faveplayer.name. And I'll show you how this works differently in a second. Then I'm going to say position. I still want to know position, but in this case I want to override the position that we entered earlier. So let's say that maybe he was a pitcher and we want to move him to another position. So we're going to do the self, just get used to that self keyword. We're still going to do position string. We might as well use that again. But in this case, to know that we used the second class of this, or it's a subclass, we're going to say now he is a and then we'll put the position string in here. Okay, so we've got that function. So if we go back to our main, and now I've instantiated fave player, but let's also instantiate fave player 2. And in this case, I've got f name and f position, and I'm going to do f2 name, which really should be the same. But I'm going to do f2 position, let's say designated hitter, because he can hit. And we'll hit enter, enter, and we'll call main. And now we see my fave player is Kershaw. Kershaw's position is pitcher. My fave player is Kershaw. Now he is a DH. Okay, it sounds like a really bad poem. What we can do now is, if we wanted to, with an F2, is instead of using fave player name, we want it to be independent of that. So a asterisk, or excuse me, a hashtag is going to be used for commenting out. And I'm just going to say print fave player 2 is still Kershaw. If I call main now, then you can see that it's using the override. So I can pull from the class, I can share information. So this works great with like company information that I want to share across a website, or maybe it's going to be constants that I'm going to use across for branding or something like that. And so the idea here is that we can save things as functions, as classes. Classes can call each other, we can subclass them, we can share information. We call the classes and functions. Functions use the class methods to be able to bring everything together. So you'll start to see how a lot of this comes together this week in your activities. So I hope this 30 minutes or so was helpful, but just gives you kind of an overview. Again, I would encourage you to use some of the Python skills outside of Zybooks if you can, to start playing with things and get used to things. And just let me know how I can help, and we'll do another video next week. All right, thank you.